Ladies and gentlemen, welcome to my presentation. My name is Shuzhu Cai. I'm Associate Researcher in Taiwan Instrument Research Institute, National Applied Research Laboratories. Today, I would like to introduce my invention. The title is Method of Transferring Nanostructures and the device having the nanostructures. Here is the outline. Firstly, I will introduce the potential application on growing and transferring gallium nitride nanorod for the next generation of a micro LED, which is kosher 3D rod micro LED. Secondary, I will introduce the van der Waals material, 2D and 3D graphene to grow and transfer gallium nitride nanorods for kosher 3D rod micro LED. And thirdly, I will introduce the preliminary result of using the growth and transfer gallium nitride nanorod and the P-type in-GaN gallium nitride nanorod using 3D graphene for flexible nanogenerator and the micro-size LED, respectively. And finally, I will talk about the future work. LED is generally used to light up our world. But some of you may not be familiar with the structure of a LED crystal. Conventional LED crystal consists of the P-type gallium nitride, yin-yang gallium nitride quantum well, and the N-type gallium nitride crystal. They are plainly grown on sapphire or silicon 111 substrate. By adjusting the indium to gallium ratio in the indium gallium nitride quantum well, the emission color of the LED can be tuned from blue, green to red color. Then the lithography and the etching process are applied to define the size of the LED. Micro LED is an emerging display technology for better contrast, response time, resolution, and energy efficiency. Micro LED display consists of arrays of micro-sized LED, which is about 100 times smaller than the conventional LED for formatting the individual pixel element. The individual pixel element consists of the micro-sized blue, green, and red LED crystal fabricated from individual wafers. The LED, the gallium nitride, and the sapphire substrate, however, have strong covalent bond, and thus make it difficult to transfer the blue, green, red LED crystal to set up the pixel array without crack and damage. That would lower the production yield of the micro LED. As the size of a pixel of micro LED getting smaller for higher resolution, the etching damage resulted from patterning the LED crystal getting severe and will result in degradation of LED performance. The kosher 3D raw micro LED is the next generation of micro LED because of the LED crystal is direct grow in kosher 3D raw structure without lithography and the etching process. And the rod crystal size could be 100 times smaller than the micro LED crystal. Thus, direct growth and the transfer of gallium nitride, indium gallium nitride kosher 3D rod is important for reducing the cost for mass production of the micro LED. The two-dimensional material such as graphene and the 3D graphene are van der Waals material with strong in-plane covalent bonding and weak interlayer van der Waals interaction, which can be applied to grow and transfer gallium nitride nanorod without covalent bond in the interlayer. Therefore, the crystal damage from the transfer of the gallium nitride nanorod grow on the graphene can be prevented as shown in the figures. The preliminary results demonstrate that the 3D graphene can be used for growth and the easy transfer of gallium nitride nanorod for flexible nanogenerator by the simple step as shown in the figures. The SEM image is here to show you the morphology of a 3D graphene and demonstrate the high density of a gallium nitride nanorod can be grown by the NB method on the 3D graphene surface in 4 wafers. From the TEM characterization, the growth of a gallium nitride nanorod would start with a smaller diameter, around 10 nanometer, which make it easier to be separated from the underlying 3D graphene compared to the gallium nitride nanorod grown on sulfide or silicon substrate. We also grow gallium nitride nanorod on silicon 111 substrates and compare the photoluminescence of a gallium nitride nanorod grown on 3D graphene and on silicon substrate. The intensity and the bandwidth of the PL peaks from gallium nitride nanorod on graphene and on silicon substrate are comparable, which indicates that the crystal quality for gallium nitride nanorod grown on the both substrate is comparable. The gallium nitride nanorod can be transferred by a tap and fabricate the flexible nanogenerator to direct power the LCD by bending and straining motion, which is not possible for the gallium nitride nanorod grown on the conventional substrate. If the P-type gallium nitride and the indium gallium nitride are grown on the gallium nitride nanorods on the 3D graphene, micro-size LED with the 30 micrometer spot size can be easily achieved without further lithography and the etching process. However, the 3D morphology surface of graphene make it difficult to control the direction of gallium nitride nanorods. The future work is to replace the 3D graphene by 2D graphene surface for vertical growth and improving the uniformity of a LED nanorod crystal to speed up the development of a kosher 3D rod micro LED. Thank you for your attention. Now I can take your question.